Hello, good morning, everybody. Hello. Hello. Tilak sir. Hello. 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 Can I start, sir? Hello. Hello. So,
Hello, sir. Sir, this is Suresh Kumar from Vignan Institute of Engineering for Women, sir. Actually, we are assigning host for you, sir, Dr. Lakshmi Narayan garu. You kindly share your screen, sir. Sir, hello. Hello, sir. This is Suresh Kumar from Vignan Institute of Engineering for Women, sir. Dr. Lakshmi Narayan garu. Now you make as host, sir. You kindly share your screen, sir. Hello. Tilak sir, can you please intimate to him, sir, through phone? Now, Mr. Lakshminarayan, Dr. Lakshminarayan garu is act as host in this session. Sir, the screen is visible, sir. Sir, whatever you are sharing, it is visible, sir. Hello, uh, uh, Lakshmi Narayan garu, can you please unmute your mic, sir? It is available in the screen on the left side, sir. సార్ చెప్పండి.
సార్ ఇప్పుడు సార్ హలో హలో సురేష్ సార్ హలో సురేష్ సార్ హలో హలో సో applications and such evolution of wireless applications required versatile antennas that can operate in multiple bands. Additionally, the ability to operate with different radiation patterns, polarized diversity, make a radiation structure more desirable. In various scenarios, the performance of conventional antennas has to be restructured to compile with the required end users. The solution to fulfill the satisfactory performance is to deploy reconcilable antennas that can be dynamically altered its radiation characteristics according to the operational environment. Such adaptive antennas can eradicate the necessity of the multiple radiating structures to attain the diverse characteristics. Here, the reconcilability is implemented by utilizing a switching mechanism using electrical switches like pin diode, varictor diode, mechanical switches, optical switches, structural alternation, reconcilable metamaterials, graphene, and also liquid crystals. So first we will discuss what is the meaning of reconcilable antenna. The basic principle of radio frequency reconcilability is to alter the physical characteristics of the radiating structure by linking or detaching various sections of it and thereby modifying the RF response. By employing different techniques, reconcilability can be realized with regarding to frequency, polarization, and radiation pattern as shown in the figure. So from this reconcilable antenna, so there are four categories: frequency reconfiguration, pattern reconfiguration, polarization reconfiguration, and combined the combination of any two, that is called hybrid recombination. So combination can be frequency and pattern, or pattern or polarization, or frequency and polarization, or three combinations of frequency, pattern, and polarization reconfiguration. So first we will discuss about frequency reconfiguration. In an advanced wireless communication, multiple antennas are deployed for performing a multiple application-specific tasks. As a result, the system becomes complex and bulkier. So the advanced portable device requires a single radiating structure to operate at multiple frequencies. This leads to the development of multiple antennas. These antennas offer only for fixed performance and cannot be tuned to users' request. In such scenario, the concept of frequency reconfiguration offers an excellent solution. This offers the radiating structure to switch its operating frequency based on the demand. These antennas plays a major role in the technology such as 5G and cognitive radio applications. So some of the frequency reconfiguration antennas. So from this first structure, that is triple band frequency reconfiguration. So by using for off circle, and also they're using defective ground structure, and they place the switches in between the L shape in the first diagram. And second one is this is one antenna. So they're using four diodes, pin diodes. It can operate in multiple frequencies and depends upon the diode operation on and off. It will change the frequency of operation. So next one is next slide is this is a wide antenna for ultra wideband applications. By using different type of frequency change, you can change. And fourth one is ultra wideband antenna for GR applications with reconfigurable band notch sticks. So from this here also, you can observe that they are placing two diodes on the top of the U shape. So by changing these diodes on and off, so we can use in different frequency of applications. So next one is pattern reconfiguration, radiation pattern reconfiguration. A single radiating structure can replace several single-purpose antennas by incorporating reconfiguration in different patterns. The radiation pattern of an antenna is classified into two types. Classified into the adaptive radiation pattern and non-adaptive radiation pattern. Adaptive radiation pattern that can be placed nulls to signals not of interest to offer the high network capabilities compared to the non-adaptive radiation patterns, which exhibit smaller side slopes but no nulls to the signals not to be interfered. Further, adaptive radiation pattern improves special efficiency by challenging the signal to the intent direction. This avoids interference by minimizing the gain in unwanted direction. In systems such as satellite and wireless sensor networks, the signal strength is received from broadside. This requires antenna to receive signals in all directions by offering the maximum gain in any direction. And the pattern reconfiguration is highly valuable in such applications. So some of the pattern reconfiguration, radiation pattern reconfiguration antennas. So this is a pentagon shape by using four antennas. So it is called quad MIMO antenna. So from the second structure, it is a pattern reconfiguration antenna by ultra wideband applications. So they can design by using different type of four diodes placed. Next one is we are using polarization reconfiguration. Polarization defines orientation of electric field of radiating, transmitting or receiving RF signals. Depending upon the orientation, it is a classified as linear polarization and circular polarization. Linear polarization further classified into horizontal polarization and vertical polarization. Similarly, based on the rotation of RF signal, CP means circular polarization is classified as right-hand circular polarization and as well as left-hand circular polarization. In wireless environment, the RF signal can be takes multiple paths to reach the destination, resulting in the multi-path fading, path losses, and shading losses. These cases, variation in the polarization of transmitting signals and creates information loss. This can be overcome by deploying an antenna having diversity in what diversity meaning is one antenna should be operating circular polarization, another antenna should be operating right circular polarization and left circular polarization. Polarized diversity can be achieved by either reconfigurable the field or modifying the radiating structure. So these are some of the polarized diversity pattern antennas. The first one is by using for rectangular, second one is rectangular, but it is to be for using for circular polarization, for left and right circular polarization for the right side, and the left side is for circular polarization for right circular polarization. And combined reconfiguration is in reconfiguration antenna design, it is possible to recombine any of its parameters like frequency of operation, radiation pattern, and polarization depending upon the requirement. Application like military, aircraft, space vehicles, and radar requires an efficient and also secure connection between the communication and users. The presence of electromagnetic interferences and pollution may affect its performance. For these applications, single reconfiguration could not provide an efficient solution, hence it requires a cognitive antenna that can switch between different frequencies of operation, different nature of polarization, and the different radiation patterns. A single radiating structure that offers combined reconfiguration make an antenna superior. Combined reconfiguration could be either the combination of frequency and polarization reconfiguration, or frequency and pattern reconfiguration, or polarization and pattern reconfiguration frequency. And depends upon the application, we can change this one. So some of the pattern reconfiguration, combination of reconfiguration, on the left side it can be exhibit for frequency and radiation pattern reconfiguration, and right side should be exhibits it exhibits for frequency and polarization reconfiguration. These are some of the examples. Now we will discuss about switching techniques. Switching techniques plays a prominent role in reconfiguration antennas design, as it alters the radiation structure current distribution by connecting and disconnecting various parts of the structure. Different switching mechanisms are available, which employ switches like electrical switches, optical switches, mechanical switches, external adjustments, and use of reconfigured material as shown in the figure. Will show the figure. For micro applications, micro frequency, the wide use of switches are pin diode, varictor diode, MEMS, and mechanical alteration. MEMS and mechanical alteration can be used to terahertz applications. For terahertz application, graphene is a good choice, and liquid crystal can be used for terahertz, mid infrared, and also near infrared and optical frequencies. So see these are the different types of switching techniques: electrical, optical, mechanical, material, and structural alternation. From electrical, we can use by using pin diode or a varictor diode or MEMS, and optical can be used for photodiode. Mechanical is motors and the linear actuators. For material is graphene, liquid crystal, plasma, and also structural. These are different types of switching techniques. We will discuss one by one. Now we'll discuss about pin-based switching. Pin-based switching is one of the popular switching technique in reconfiguration antenna design. The pin diode is a current control device and behaves as a variable resistor RF frequencies. Control of high RF signal power with a small control voltages, less susceptibility to the electrostatic discharges, damages, high frequency, high figure of merit than the field effect transistor makes pin diode as a better choice to perform the reconfiguration at micro frequencies. The realization of pin diode is done by using lumped elements, the resistance, capacitor in this one. So from this figure, we can observe that when we are placing a diode in between any structure, so it can operate as a on or off by connecting a biasing voltage. So when it is on, it is a combination of inductor and resistor. When it is off, it is a combination of inductance and is a parallel combination of resistor and also capacitor. A serial RL circuit represents an equivalent circuit of pin diode active state, where the lower value of R allow the current to flow to radiating the sections. So we need to choose a resistance value as small as possible, whenever it is on state. When it off state, pin diode can be modeled as a RLC circuit where L is a series with the parallel combination of R and C. Here, the higher value of RC prevents the current from flowing between the radiating components. So this is a CST. By using CST, we can design any reconfiguration or HFSS. So next one, forward bias pin diode provides on state by setting a short circuit, and reverse bias provides off state by setting open circuit. In both the case states, the inductor, whatever the inductor value is kept constant, and it performs choking by allowing a DC and also blocking RF. Apart from the radiating structure, pin diode can also be integrated into the ground plane to accomplish the reconfiguration. So we can place the pin diode on the patch, or we can place a pin diode on the ground surface of your antenna. So the current of the less than 10 milliampere has been used to bias the diode. The presence of DC biasing circuit will have the notable biasing. A broadband microstrip to the coplanar strip transition is used to feed the antenna. For direct excitation of pin diode, an impedance transformation can be used. So one of the drawbacks of this pin is reconfiguring using pin diode switching mechanism may result in a degradation of efficiency and get limited in terms of power management, isolation, and also matching issues. These are one of the drawbacks when not using a pin diode as a on and switching mechanism. So varictor-based switching is varictor offers accurate tuning by varying its capacitances. The high resonance frequency is produced by applying an increasing reverse voltage, which increase the depletion region and decrease the capacitance. and the resonance frequency is decreased as capacitance is increases. So comparison of features of complementary metal oxide varactor with respect to micro electromechanical system varactor shown in the table. So from this table, we can conclude that, so when you're using MEMS varactor, there is no notable leakages and the quality factor should be also increases. Tuning range also must be most valuable in case of MEMS varactor. It always stores less losses. That is important when you're using MEMS varactor compared to CMOS varactor. And next one is RF MEMS based switching. Radio frequency MEMS is key technology that enables the next generation of radio platform. Integrating the RF MEMS switch with a radiating patch over the same substrate will help the attain tunability in its operation. Depending upon the signal path, MEMS switches can be classified as series and shunt type. Likewise, based on the mechanism of activation, it can be either electrostatic or magnetostatic. A shunt switch is preferable over the series because of the reducing parasitic element and also high power handling capability compared with the series switch. RF MEMS switches have the low instruction losses, less lightweight and the small size, high isolation, high quality factor, good linearity, tunability, and ability to handle the power. On the other side, it has low switching time and also high cost. That is a main drawback in case of RF MEMS switches. So these are the comparison of solid state switches and also RF MEMS switches. So and observe the frequency range. It is DC to when out operating F max means operating frequency maximum. Instruction losses should be less in case of MEMS. The isolation is also good for low to high and as well as low frequency as well as high frequency. Return loss and repeatability is good. And switching speed is slow. Settling time is slow. Rise time or fall time should be in 10 of milliseconds. Power handling capability must be high. Lifetime must be medium. Immunity to electrostatic discharge is high. Sensitive to mechanical vibration. That is the main in case of RF MEMS switches. Now we'll go for optical switching. Optical switches have the gain popularity in the reconfiguration and design as it does not require any metallic element to feed the structure. Here the switching can be achieved using a doped silicon, means photoconductivity switches. The optical fiber can pass across the holes, creating in the substrate and ground plane. Through the optical fiber, the laser light is coupled transversely to the photoconductive switches. Further light from the laser diode can be coupled effectively by integrating the laser diode with antenna using copper pieces. RF conductivity of the doped silicon changes from semiconductor material to the metal-like material when exposed to a laser light. This requires optically switches antennas to be incorporated and also properly packed in the commercial smart devices. The important consideration of optical switches are the density of the plasma development, carrier lifetime, and also wavelength of the light. So comparison of electrical properties of the optical switches with pin diode and also RF switches. So voltage range should be less in case of optical switches. Current is required minimum, which should be maximum. And power consumption is also must be in case of RF MEMS switch is less. Switching speed is very less in case of optical, and isolation is also good. And losses in dB are also very excellent in case of MEMS switches compared to remaining switches. Structural alternation also mechanical based switches. Switching using lumped elements, RF MEMS and photodiodes requires external biasing, which degrade the antenna performance. Optical switches requires incursion of laser to the provide optical signal, which makes the system complex and also costlier. These can be overcome by utilizing structural alternation as an alternative to the achieving a reconfiguration. Rotation of radiating structure can be done manually or it can be controlled using any control boards. Moreover, the physical rotation of antenna does not require biasing circuitry but may create an impedance mismatch that degrade the antenna performance. Hence, the next alternative will be the use of motors and actuators. This mechanical based switching facilitates excellent control over the reconfiguration, but the speed of the reconfiguration is quite slow. The cost is one of the factors that affect the use of mechanical based switches. One may use many number of actuators that required. Thus, it is important to know that the number of actuators required to perform the reconfiguration, actuator position approaches, actuator type, and the alternative approach for the mechanical reconfiguration antennas. So material based switches is For terrace applications, reconfiguration can be achieved by reconfigured material like graphene, liquid crystal, and as a substrate. A lot of research is carried out the realization of reconfiguration using reconfiguration materials as it does not require any structural changes of radiating structure to achieve the reconfiguration. Plasma-based antenna replace the requirement of metal and also offer the fast switching. Graphene is a two-dimensional material that has distinct material, mechanical, electrical, and also optical properties. It performs like a metal at the high chemical potential value. Graphene is the good choice to perform the reconfiguration in terrace antennas. Graphene-based elements placed near the radiating patch will offer the reconfigured frequency response. Multi-layer graphene is high efficient than the single-layer graphene. Thus, the minimization in the inversely proportional to the efficiency. By dynamically changing its chemical potential, it is possible to control surface conductivity. To reconfigure the graphene-based terrace antenna, the chemical potential needs to be varied from 0.3 electron volt to 0.9 electron volt. As the chemical potential rises, the resonant frequency increases, but the graphene surface impedance is decreases. Transparent antenna designs are advantages for different applications like concurrent solar power harvesting and also recurrent antennas for RF energy harvesting. Indium thin oxide is a liquid semiconductor that subsists over its glass surface for RF signal conduction. Silver nano wire is more conductive than the ITO and also transparent. They're expensive, but it improves the efficiency also reconfigurability of the antenna. The liquid crystals are all classified into different types of such as nanometric and isotropic, holistic phase, etc. Among these, metallic LC acts as the best choice due to this high dielectric, antiscopicity, and also ease of the working. Nanometric liquid crystals have also been extensively used in optical frequency applications such as display and also laser production. This can be excited and also its dielectric properties can be modified by providing electric field biasing. This will later antennas radiation pattern also operating frequency. So what are the applications of reconfigured antennas? We can use in cognitive radio and 5G and MIMO applications. When it comes to the cognitive radio, in wireless communication, spectrum are getting allowed to multiple users based on the wireless standards. Some applications find a lot of users and some find few users. Due to the increasing demand, the spectrum with the more users gets overloaded and these existing spectrum security. So this creates an unbalanced spectrum usage. The cognitive radio is a potential solution for the further wireless communication system to improve spectrum utilization by allocating the primary users to unused spectrum to the secondary users and thus reducing the spectrum sacrifice. So 5G systems are in recent year, antenna design 5G communication is getting attraction among the researchers as it is offer the high data rate. 5G technology intended to provide ultra low latency, high data rate, better reliability, and high availability. The usability of 5G is not restricted to mobile wireless applications and is intended to provide a scalable and also inexpensive network in which the main factors are system minimization, modulus instrument, lightweight, and cost effectiveness. Recent research progress in the development of a simple and low-cost, reconfigurable, flexible, and conformal antennas for 5G communication. In various scenarios, millimeter wave means when our operating frequencies changes from 22 GHz to 46 GHz because the 5G communication is category divided into mid-range, also low range, and also high range. When it comes to high range, it is from 22 GHz to 46. If mid-range is 3.2 to 4.2 GHz, lower range is below 3.5. So these are the use of 5G system to overcome the path losses and other attentions while maintaining the high data rate. Directional antennas with wide bandwidth, diverse polarization, and high gains are required. Also, frequency reconfigurability is highly influential in the 5G antenna design as it enhances the data throughput by increasing the bandwidth and also capacity. Switching over multiple frequencies, the ability to change the spatial configuration and capability to alter the orientation of transmitting RF signals make the reconfigurable antennas suitable for 5G communication. Further efficient feeding networks, reduce the mutual coupling, high gain, and also high efficiency will make the advancing 5G antenna design more attractive. So the third application is MIMO antenna, increasing throughput in fading essential for reliable communication. This can be achieved by using MIMO system, which has two or more radiating structures for transmitting a receiver. So when I design antennas, more than one antenna on a single substrate, then it is called MIMO system. While designing an antenna for MIMO application, channel capacity loss and correlation coefficient are the more important parameters. You have to concentrate these two parameters. The goal of the reconcilable MIMO antenna system is to optimize the device performance with its ability to efficiently use the available spectrum resources and also provide high gain. Channel capacity can be improved by suitable antenna design that can adapt to any changes in RF environment. The implementation of reconcilable MIMO antenna system could dramatically increase data efficiency and directivity in the correlation coefficient. Meaning is what is meaning of the once the section is complete, I will discuss what is meaning of correlation coefficient. These are comparison of various switching techniques. So pin switching, variegated diode, and RF MEMS based optical switching, spectral, and also mechanical. These are the key features and also shortcomings. So from this, what are the discussions till now? We will complete into one comparison table. And this is the manufacturing of antennas should be available in Vignan, Vignan campus in Duvara. So how to manufacture the antenna? So once you're designing an antenna on in HFSS or CST, first to save this file, and next one is the antenna should be converted. So once design of antenna is completed, now we have to convert into a DXF file. Once DXF file is converted, now what is the procedure to change into DXF file to MTS file? How to find the correlation coefficient? Sir, once it is completed, I will start what is the meaning of correlation coefficient and how to minimize the correlation coefficient. I will discuss it. So these are the steps for converting your antenna DXF file to MTS file. So once it is converting to, so when I observe this file, this loss diagram, this is a procedure. So whenever see observe the last figure, what are the green color is indicated. This is your radiating patch, and what is the outer ray? Outer ray is representation of by using light blue color. It represents your substrate length and width indication. So next remaining part of this to be is called remove the copper from your radiating patch. So these are the references. Thank you. So now I'll discuss what is meaning of correlation coefficient. Correlation coefficient is nothing but when I'm placing the two antennas side by side, so how much of mutual coupling should be exist between two antennas. So when I design any MIMO antenna, the correlation coefficient value should be less than 0.5. You have to maintain. Means the mutual coupling should be decreases. Correlation coefficient value should be increasing value. That is the main intention of correlation coefficient. Any questions? Hello? Hello? So we can find the correlation coefficient from your design. Once it is design is completed your MIMO antenna, so we can directly find out your correlation coefficient value from HFSS and the CST. There is a procedure to find the correlation coefficient, but it is in the two methods. When I design antenna in CST, it will give the correlation coefficient by using S parameter method. When I design antenna by using HFSS, it will use the correlation coefficient by using radiation pattern method. So according to these two, the best method is radiating method is better one compared to S parameter method. Hello? Hello? Suresh sir? Hello? 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 Hello. 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 No data. Hello. 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 Anyone is there? Sir. Suresh sir.
Hello.
Hello. Sir, చెప్పండి sir. Sir, any questions from the participants? Hello?
Sir, just a minute. Sir.
Okay, okay.
Sir, now everyone can ask a questions to Lakshminarayana sir by unmuting your mic, sir. Dear participants, you can unmute your mics and you can ask any questions regarding this session, whatever he has given. Welcome to, you can ask if you have any doubts regarding this session. Dear participants.
Yeah, so you can ask anyone, sir. Hello?
Dear participants.
Sir, thank you so much, sir, for giving valuable information to participants, sir.
Okay,
Hello.
sir. Thank
Hello,
you very
sir.
much for.
Thank you
Tell
so
me,
much,
sir.
sir.
Okay, okay. Thank you, man.
Yes, dear participants, if you have any doubts,
Sir, any questions?
please ask to sir. He will clarify your doubts. And sorry for some small technical issues.
Okay, no problem. No problem, sir.
Please
It will happen
ask
for online.
questions to sir.
Dear participants, if you have any doubts, please ask to sir regarding this session.
Somebody asked me how to find the correlation coefficient. Hello? Hello? Anyone?
Thank you, sir. Thank you for your valuable
Okay,
session, sir. Regarding
okay, sir.
antennas and various patterns of antennas and how can we excite this antenna by giving the various varying the pin diode as well as the by varying the by giving the different structured diodes. Thank you very much.
Thank you. You're welcome.
Sir, wait a minute, sir.
Okay, sir.
Sir, someone asked one question, sir. How we can ensure appropriate biasing for switching operations, sir?
So whenever designing antenna, so we need to apply the biasing from 1 volt to 5 volts, sir. So by changing the biasing voltages for externally, so then we can identify the what are the reflection coefficient, how to change depends upon the biasing voltages also. So we need to change the voltage biasing voltage externally, and
So this
later on by
biasing,
in the simulation process also.
so this biasing voltage, will it depend on the switching device that we are using, or is it some fixed value?
No, it is not a fixed value. It can variable. So for pin diode and watt diode also. So whenever change the biasing voltages, it will affect your resonance frequency changes, and the operating bandwidth also must be changed.
And also, sir, like there will be interference between DC and RF signals. So how we can avoid that? Like,
so whenever placing your reconcil diode, so on the ground plane instead of using on the patch, so the most of the mismatching can be eliminated, sir.
okay, sir. Okay, sir. Thank you.
Thank you. Is there any questions? Can I conclude this section, sir?
Yes, sir. Sure, sir.
Yes, sir. Yes, sir.
Thank you, sir. Can I leave now? Sir.
Dear participants, we are going to have one more session from, it is going to start from 7:30 onwards. Kindly join by 7:30. Thank you. Thank you very much. Tilak sir, hello. Can anyone respond? Tilak sir, actually, we are going to have one more session. It is going to start by 7:30. It will be given by Mr. Sachin, Dr. Sachin Garu, who is from MVZR, Vijayanagaram. We will meet at around 7:30, before 7:30. Thank you. సార్ ఒకసారి సార్ని ఎంటర్ అవ్వమనండి, నేను చూస్తాను. హలో సార్ ఈజ్ మై ఒకసారి సార్ 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 ఒకసారి మీరు మాట్లాడండి సార్ 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 సెల్ ఫోన్లో వినిపిస్తున్నారు సార్ సెల్ ఫోన్ అసలు ఆఫ్ చేయండి సార్ సార్ హలో సార్ ఈజ్ మై వాయిస్ ఆడిబుల్ సార్